The scariest truth about our universe. Welcome to the Understanding the Universe channel. In today's episode, we're diving into the scariest fact about the universe. Get ready to explore one of the most mind-blowing and unsettling truths about our cosmos, a discovery that will leave you questioning everything you thought you knew. Stay tuned as we unravel the mysteries of the universe together. Have you ever gazed at the night sky and wondered where it all leads? The stars, the galaxies, the endless void. It all seems so timeless, so eternal. For centuries, humans have been captivated by the mysteries of the universe, asking questions about its origins, its present state, and its eventual fate. Today, we know more about the cosmos than ever before. But the answers we've uncovered are as astonishing as they are unsettling. Perhaps the scariest truth about our universe is the inevitability of an ending, one that feels far less dramatic and far more eerie. The universe, vast as it is on a slow path toward a fate known as the Big Freeze or heat death. It's not a fiery end marked by explosions or collapsing matter. Instead, it's the opposite, a cold, quiet decay that might mark the death of everything we know. Let's dive in to explore this chilling future and the science that led us here. For much of history, we didn't even know the universe was expanding. It seemed static, infinite, and unchanging. However, this idea began to shift in the early 20th century when astronomers discovered something profound. Galaxies outside our own Milky Way were moving away from us. With this observation, scientists determined that the universe is not fixed, it's expanding. But what would this expansion ultimately mean? In the early days of cosmology, two leading theories emerged to predict the universe's fate. Many scientists thought the universe's expansion might eventually slow down, perhaps even reverse, due to the force of gravity. This idea led to the concept of the Big Crunch, a scenario where the universe would collapse back in on itself, leading to another explosive, Big Bang-like event. The second theory was less optimistic. If the universe's expansion continued unchecked, everything would eventually drift apart forever, creating vast distances between stars and galaxies. Over time, this would result in a dark, cold, and lifeless expanse. This hypothetical scenario would become known as the Big Freeze. Initially, the idea of expansion lasting indefinitely was considered unlikely, but everything changed with the discovery of dark energy. In the 1990s, astronomers made a groundbreaking discovery while studying supernovae, or exploding stars. What they found was surprising. Not only was the universe expanding, but it was doing so at an accelerating rate. Something was pushing galaxies apart faster over time. Gravity, instead of slowing the expansion, was being overpowered by a mysterious force. This discovery shocked the scientific community. Instead of a slowing universe poised for a potential collapse, they realized the cosmos was heading toward a much different and potentially far more unsettling outcome. The force responsible for this acceleration was termed dark energy. Dark energy is an intriguing phenomenon that remains one of modern science's greatest mysteries. It's invisible, it doesn't emit light or interact with matter directly, and yet it makes up a staggering 68% of the universe. It acts like a kind of anti-gravity, pushing everything outward, slowly and steadily stretching the universe to its limits. To understand dark energy, think of it like an invisible push, working against gravity. While gravity tries to hold everything together, dark energy does the opposite. Its nature is so puzzling that scientists still don't fully understand what it is or how it works. But what we do know is that dark energy is everywhere, in every part of the cosmos. It drives the expansion of space itself, meaning over time, galaxies are moving farther apart, and that distance grows faster and faster. To put it another way, imagine the universe as an inflating balloon. The galaxies are like dots on the surface of the balloon. As the balloon inflates, the dots move away from each other. This analogy helps us understand how space is stretching, carrying galaxies along with it. But unlike a regular balloon that inflates at a steady rate, dark energy causes this balloon to expand faster and faster. The more space stretches, the more dark energy there seems to be, creating a feedback loop of accelerated expansion. What does this accelerating expansion mean for the future? At first glance, it's hard to grasp the scale of these changes, but the implications are profound and sobering. As galaxies move farther away from each other, the distances between them will increase to the point where they can no longer interact. Our local group of galaxies, the Milky Way and its neighbors, will remain gravitationally bound, but much of the universe beyond our region will eventually disappear from view. The light from distant galaxies will no longer reach us because they'll be moving away faster than the speed of light itself. Over billions of years, stars within galaxies will start to die. Every star, including our own sun, has a lifespan. When stars burn through their hydrogen fuel, they extinguish, leaving behind remnants such as white dwarfs, neutron stars, or black holes. As time ticks on, fewer and fewer stars will form, plunging galaxies into darkness. At some point, even the atoms that make up matter could start breaking down. The universe will become a place where space is vast and empty, with temperatures dropping ever closer to absolute zero. This bleak future is known as the Big Freeze, or heat death. The Big Freeze describes the ultimate fate of an endlessly expanding universe. In simple terms, it's the idea that as space expands indefinitely, all energy will spread out more and more, becoming so diluted that nothing can happen anymore. Stars will burn out, matter will degrade, and the universe will approach thermodynamic equilibrium, a state where no heat or usable energy remains. Temperatures will plunge toward absolute zero, the coldest temperature imaginable. At this point, no chemical or physical processes can happen. Nothing can change. The universe will essentially die in a state of stillness, devoid of structure, light, or activity. This isn't an abrupt apocalypse. It's a slow, gradual process taking place over trillions of years. But that doesn't make it any less unsettling. It's not just the death of stars or planets, it's the end of everything, even time itself as we understand it. To fully appreciate the enormity of these changes, let's outline a rough timeline for the universe's grim destiny. Now, through 100 billion years from now, galaxies outside our local group will move so far away that their light will stop reaching us. The universe will start to look empty beyond our immediate region. 10 trillion years from now, star formation stops as galaxies run out of gas to form new stars. Existing stars begin to burn out, leaving behind only dead stellar remnants. 1 quadrillion years from now, black holes dominate the universe as most matter has collapsed into them. Over even longer periods, black holes will lose their energy through a process called Hawking radiation, leaving behind a faint and empty cosmos. 10 to the power of 100 years and beyond, matter itself disintegrates. The universe becomes a cold, sparse void with no way to sustain structure or energy. The Big Freeze is complete. While the Big Freeze and heat death are inevitably far beyond our lifetime, the idea of an ultimate end to the universe has profound implications. It raises questions about the fragility of existence and the nature of creation. How do we find meaning in a temporary universe? What does it mean to be alive at a time when stars still shine and galaxies still exist? Although it's natural to feel unsettled by this knowledge, there's also an extraordinary beauty in it. We live in a universe that allows us not only to exist, but also to understand it. The fact that we can measure its size, interpret its dynamic behavior, and predict its future is a testament to human curiosity and ingenuity. The universe's distant fate should remind us of the uniqueness of the present moment. Right now, stars are still forming, galaxies are still colliding, black holes are still consuming matter and releasing energy. Countless wonders are still unfolding across the cosmos every second. We're alive in a time when we can study these wonders, marvel at their beauty, and piece together the story of our universe. Instead of a source of fear, the story of the Big Freeze can inspire gratitude. It's a reminder that the opportunities we have to learn, to explore, to exist are fleeting and precious. The universe is an incredible place, filled with mysteries that push the limits of our understanding. While its fate may seem bleak, its story is far from over. Today, we stand at a unique crossroads, equipped with the knowledge to appreciate the cosmos and our fleeting role within it. We truly appreciate your time and curiosity as we explore the wonders and mysteries of the cosmos together. Your support means the world to us, and it's what keeps us inspired to bring you more exciting content. Stay curious, keep asking big questions, and never stop exploring the universe. Don't forget to like, share, and subscribe for more cosmic adventures. Together, we'll continue uncovering the secrets of the stars.